E times mu of xj, where xj's are components of x. Therefore, if x is not connected, then it will go outside. What is the advantage? Advantage of this way of answering this question is it is kind of algebraic and can be extended. So vector bundles we have already defined. So let A be a C star algebra, or at this moment star algebra will do.
So rank of E is dimension of
Rank of E means dimension of E on X. Now on connected components, this is constant function. So this is a.
So you should have an index J there.
Yes, that I have got.
On the E. On the E.
These are connected components.
On the connected component, the rank for each connected component here.
Yeah. Yes. Okay. So let there be a C star algebra, and I take a projection P from A. Now let us come to this good probability measure business. So we know what is a probability measure in this framework. So I have a state tau. Tau is a state. We will take tau to be actually terrestrial state. So and tau is faithful. Okay.
So this puts some constraint on the algebra, on the C-star algebra.
Yes, this puts some constraint on the system. You are right. And so what is it being done here? Let us look at this construction. That construction is, first of all, that is not in A, so I have a projection in A tensor MNC or an idempotent. First step we did was we looked at trace of Px. So trace of Px is really x going to trace of Px. This is the function identity tensor trace applied on P. It is an element of the algebra. So this function is really this element of the algebra. This one belongs to algebra.
Trace is on A, right?
Trace is on
Trace is on
MNC.
That's MNC.
Trace is on MNC. So it is a function on the algebra. And now I apply tau on this. So tau of this is really the integral mu E, that is same as that, and I can also write it as tau tensor trace of P. I will also denote this by this symbol tau P. So I sort of try to write this as a pairing between two quantities. On the one hand, vector bundles, and on the other hand, this is a measure. We'll think of it as some object which pairs with vector bundles. Or here, projection and a trace, but we'll think of this as some object which pairs with this. Pair meaning, no, I cannot elaborate the meaning of pair in here. So, it is like a vector pairing between two vector spaces or two groups and things like that. Okay. So if I have something like that, so say let A be a C-star algebra such that first of all there exists a so meaning of faithful trace is clear to everybody. That means tau of x equal to 0 or x greater than equal to 0 implies x equal to 0. trace means tau of AB equal to tau of BA. State means tau of x is greater than equal to 0 for all x greater than equal to 0, tau of 1 equal to 1. So, if I have something like that, tau, such that tau tensor, maybe I should just write tau of
Unit 2, sister algebra.
Yes. You must keep in mind that everything is getting recorded. That's why even if you do not point out, you should mention to the audience. Some of the owners goes to their walls. So tau p, this is a faithful trace. So suppose somehow, okay, so p is a projection, therefore p is between 0 and 1. And tau is order preserving, therefore it is in the interval 0 to 1. Suppose.
What did you write there?
Here?
On the right.
Here, tau. Sorry, you wrote it out. It is p. P is between 0 and 1. So if tau p is between 0 to 1 and also it is in integers, then we know that then p must be 0 or
That's a very funny way of saying
1. That's a very funny way of saying, but that's how you do it. That's why.
Is that how people write?
Which one?
0, 1 intersection Z?
No, that's how the proof goes. You first realize that, that is an interesting thing. First of all, using this fact in step 1, you realize that it is in 0, 1. By a completely different argument, and that's what we want to do, you want to realize that it is in Z. It does not come straight like that, so it is a counting argument. So from that it follows it is in Z. That's why I am writing Z, not N. It is a counting argument, you do not know what it is, so otherwise we might say why am I putting Z all the time, not N. Counting argument leads to Z, yes?
A is a unit sister algebra.
Yes.
P is a non-negative contraction.
Not a contraction, it is an idempotent. P is an idempotent. P is all around an idempotent. This is such that,
Just add.
yeah, P is an idempotent. P is an idempotent.
What is the statement? That if tau p is there, then p is either 0 or idle.
Let me first state it for projections and then we will do the idempotent piece. Because otherwise, if I just state it as an idempotent, then p less than equal to 0 or 1, meaning between 0 and 1 does not make sense. Therefore, let us first do it. So p be a projection.
So by projection you mean self-adjoint idempotent.
Self-adjoint idempotent. Such that this happens, then p must be 0. Let us do this and then we will do some simple algebra to conclude that this will imply the same statement for the idempotent. So our task is, given a specific choice of the group, we want to produce traces. So far everything was easy. We want to have a recipe for traces that will have this kind of property. This is automatic, this property.
Can you just say a few words about the implications of a C-star algebra having a faithful trace?
Meaning why? No. That is your general apparatus algebras. That is your general apparatus algebras. I will leave it up to you. So, yeah. So this is a restriction. I will come back to this restriction in the next class. Oh, no, everything is getting recorded. I cannot come back to this restriction. The restriction it imposes and sort of its consequences. It imposes certain restrictions, and therefore, if you are similarly guided by these restrictions, then maybe at times you are misled on the development of the subject. It implicitly assumes, if you assume that A is of this kind, then it implicitly assumes something on the fundamental algebra generated by it and so on. Therefore, it restricts your domain on which you can play these games. So, therefore, yeah. later on or maybe later. So now we want to come back to the main part, which is construction of traces. This is the real thing. So it is because of this entire story is to motivate this definition. This entire story is to motivate this definition. A freedom module means the following thing. It is a pair. It is a pair. A freedom module is a.
This is just an observation of what.
This is an observation which is not very difficult. It is an easy observation, right?
It's a trivial thing.
It's a trivial thing. Exactly.
You are saying it's faithful.
Exactly.
Exactly.
Exactly. So it is trivial. What is not trivial is construction of such objects ensuring it belongs to Z. This entire argument, whatever I do, is very trivial. Right?
Yeah, no, so you want to construct a tau so that tau t belongs to Z for every p.
Yes.
So that is because
I want to construct exactly so. So this is a lemma. This is the lemma. This is not the theorem. It is a lemma. It says that if I can construct, if I can construct a trace tau such that tau t satisfies this, not be for every p, then I from this I can convert p equal to 0, 1. If it is true for every p, then I conclude it has no non-trivial idempotency. So task is real construction of such an object satisfying this for every p. That is the rule. Okay, and as you can imagine, this quantity must solve some counting problem, otherwise you cannot quite conclude it is in Z. So I come back to this definition. This is a pair where this algebra A is represented in B of H, maybe. Okay, no problem. F is an element such that f squared equal to identity, f equal to f star, and this set of all these A's such that pi commutator A is compact, is dense in A. I will call this A infinity, and this is even. This is called even if there exists a grading gamma. So what is a grading? Again, something similar to F. That means gamma equal to gamma star, gamma square equal to identity. Gamma commutes with this object and gamma anti-commutes with F. Such a thing is called an even freedom module, and we will need something slightly more. So let HF be an even freedom module such that if commutator pi A, instead of demanding it is a compact operator, we demand it is trace class. So I say
your grading the algebra is being graded, right?
yes.
Gamma equal to gamma star. What about the commutator with gamma? Pi A commutator gamma.
So pi A commutes with gamma.
Oh, that's up there.
Yes, right. Sorry. So pi A commutes with gamma and anti-commutes with F. Pi A commutes with gamma and anti-commutes with F. And now instead of demanding that this thing falls in compact operators that is dense in A, I assume that it is trace class that is also dense in A. Given such a thing, so then I should check. maybe one normally doesn't put this algebraic trace, but just to separate out that just by demanding this, such a thing may not be positive. So all you verify is the cyclicity property. So if I call this tau, then tau AB equal to tau BA.
But I have written the B1, is it?
B1.
Doesn't one call it sort of infinite small order 1 or something?
I don't know. Could be. There could be.
Because if it is in BB, the shattered class P,
Right. So
infinite small order P, and
yes, I am just not sure about whether if it is in B1 or in the Ismail traceable class, then what you say they are coming. Yes, but I think that is infinitesimal of order 1.
so that is order 0. Anyway,
No, compact is order 0.
compact is order 0.
Compact is order 0 and Ismail traceable is order 1.
Can you tell what is the intuition behind these definitions and
Yes,
some
yes.
examples also?
Yes. So if I want to discuss one example, and then first of all I want to discuss its proof, and then I want to come back its intuition behind, or more importantly, I think maybe I should say, how do you interpret this quantity? How do you interpret this quantity? By intuition, you really mean that. You mean that what is the interpretation behind this object? And I think interpretation behind this object comes from the following reason. So we will eventually prove that. So this is a linear functional. This is a linear functional. So if I have a projection, so that can be organized into a group. So interpretation. You must be admitted that this interpretation is not straightforward, but that is because we are really trying to extend something beyond its usual framework, the framework which we are used to. So
This trace is the usual trace of your.
no. So this one is the usual trace. This is the trace of pH.
Yeah, trace of pH.
Yeah.
And that is finite because they have assumed so.
Because I have assumed so. Exactly.
That is F comma pi, right?
F comma pi. A is an abstract.
That's the commutator.
That's the component.
So it says that gamma of 1 is 0, right? So understand that. What says what? Because F commutes with
Yes.
1.
Yes.
F anti-commutator.
1. The pi of 1 is 1, right? So
No, there is no problem. There is no problem. Tau is a linear function of satisfying this property. I am not saying anything about positivity.
no, I'm saying tau of 1 is 0.
Tau
Yes.
is 0. May not be so. So in the example it won't be. Even assuming pi to be a unital homomorphism. If pi is non-unital, it may not be 0, and in our example it won't be.
It won't be.
It won't be. So it may not be 0. If pi is unital, pi is.
And what would you do if it is an odd freedom module?
Odd case I am not discussing, because I have not discussed in other names also. This is just the first case. This is the first case. I am not discussing the odd pairing. Interpretation of this concept is the following. First of all, what does tau do? So tau, or freedom modules, I should say. Freedom modules pair with vector modules projections. So intuitively, the functional algebra is really kind of captured by these quantities. Therefore, your space is something which pairs with functions. So that leads to this idea that space is something that pairs with functions. Therefore, as this object pairs with this object, so you should
Duality.
Duality. Now, I am not being precise, right? For example, I have not.
In the Gelfand sense.
I have not. No, not really. Meaning, I have not kind of packaged these objects into groups. So ideally, these are packaged into groups, and then we should have elements of another groups which pairs naturally with this. There is a natural pairing between this and that. And therefore that indicates
So in the function case, that is classical case, what would be the Freedom module?
so I will write down. I will write down that in a moment. But this is the intuition. If there should something that should pair naturally with these objects, then there should be kind of description of somewhat finer properties of spaces.
I think you should say a few more words on the concept of pairing here, because it's quite subtle.
Concept of pairing is these objects can be packaged into abelian groups. Then these are also elements of abelian groups which has a bilinear map between this and that landing into Z. I will write down that bilinear map in a moment, and that's how we will conclude that it belongs to Z. So there is a bilinear map between this object and that object.
See, like the classical case, you had the mu and e,
Yes.
that they were pairing.
Yes.
Okay. Here
also, just I mean, when I describe the pairing, I will not describe these objects, what they are. Their modulus of equivalence relation will form a group. It is this equivalence relation which I will skip. I will describe the pairing. So let us come back to pairing. Even this proof is interesting, and maybe I will do this argument at least in the next class. So what is the pairing? So what does a freedom module do? Let us use this concept, okay? So I look at this quantity. First of all, if H, F, gamma is a freedom module, then I can look at this representation. Algebra is represented H, therefore I can abbreviate H is Cn. I can look at F tensor identity, and I can look at gamma tensor identity. So let P be a projection. Then, so H decomposes as a direct sum of two Hilbert spaces, H plus and H minus, where plus minus 1 eigenspaces of gamma. Now, this algebraic representation commutes with gamma that says this map, instead of pi p, I will write p. They really respect this decomposition. And if anticommutes with gamma means if really switches these two objects.
statement? I thought, sorry, can you repeat that statement?
Which one?
So
P computes with gamma
P plus minus.
will send P plus will send H plus to H plus, P minus will send H minus to H minus.
P is the P plus minus is the restriction of P to the H plus minus.
Yes.
And they're leaving these invariant.
Yes.
That's some assumption.
No, P computes with gamma.
Consequence.
Therefore, right? Because gamma P is
Now, P sends H plus to H plus, P sends H minus.
Exactly.
You also get plus minus there.
So I denote this P restricted to H plus by P plus. If you like, you can think of P send H plus to H plus, H minus to H minus, or you can think of the restricted operators. I call them P plus minus.
You can do that on this side.
On this side,
For F it is just F.
I cannot do because you are right, you are very right. So probably I should say I do not know really, but you are right. So maybe I should write it separately. You are very much right. So this is inconsistent notation. So F maps F of H plus minus
H minus plus.
They are exactly the same.
no. F sends H plus to H minus to H plus. So let us write down. If I write it as a matrix,
I'm saying it's an equivalent.
yes. And R and S are really equivalents between these two spaces, H plus and H minus. So F is like that. So now I can look at this map, which is P plus F P minus. This is a map from P plus of H plus to P minus of H minus. And this map has finite dimensional kernel and co-kernel. And so this quantity, if I compute, so now there are two quantities, right? On the one hand, I just describe, starting with such an object, I can write down a function as tau. Maybe tau of A is half trace gamma f, this quantity. So I can evaluate tau tensor trace on my P.
Why will it be P square?
Because it is an assumption. That's what I assumed at the beginning.
Yeah.
So this quantity is nothing but dimension kernel of this map P minus F P plus minus dimension co-kernel of P minus F.
Why do you say that it has a finite dimensional kernel?
So that is easy to see. That it has got finite dimensional kernel and co-kernel, so let us prove it.
We have one co-kernel.
Right. So I multiply this by this pattern.
P is in A or in MN. P is in A.
You use the commutator.
Otherwise, if P is not from A, MNA, you just make everything affiliate. That's why I must say that.
Tau tends trace, so that means P is in.
Here, this one I am using for MNA. My notation is maybe inconsistent. If you want to use that MNA part, then this trace corresponds to that. P is in MNA.
P is in MN.
P is in MNA.
So that P plus and P minus is those belongs to P.
This is the affiliated function. So
Ah,